Hello, my name is Wink Giesman. I'm co-founder and CEO of the Things Industries, and we're helping companies around the world building IoT applications, IoT networks, together with an ecosystem of 100,000 developers. I'm going to tell a story how we, with our team, created a global IoT network with a global developer ecosystem in 5 years. So 5 years ago, when I sold my previous company, I was looking at a new challenge. So I was looking into these hypes, big data, machine learning, and Internet of Things. And if I did some research, then you saw that large research institutes were predicting billions of devices being connected and huge commercial opportunities in the Internet of Things. And although I'm a technology guy, I didn't really know what actually Internet of Things was, so started Googling it, and then if you Google it, you see that around 25 years ago, we were promised a smart fridge. So basically nobody has a smart fridge, so where is it right now? And then if you're looking for examples of Internet of Things or smart objects, then you see these examples like a smart fork that counts how many bites you took that day, or a smart coffee cup that measures how much coffee you drink, or a smart toothbrush that reinvents brushing teeth, and even like a device that counts the eggs that you have in your fridge and then connects it to your smartphone, so you always know how many eggs you have in your fridge. So like all of these ideas, like I thought this is just a big hype, like this is like all these things are not really solving a real problem. And then yeah, I think the conclusion, if you look at where IoT is at, is that it is quite a disillusionment. And you probably know the Gartner hype cycle. So where IoT is actually like almost near the bottom, right? So like where are all these connected devices? Where is this like big IoT dream? So so yeah, I was not really convinced. And a few months later, I was at a meetup in Amsterdam, and somebody told me about a technology, LoRaWAN. And it's a technology to connect things. It's a technology to build the Internet of Things. And I was very skeptical towards the whole concept of Internet of Things. But I was looking into it, and it was actually pretty cool. Like as a technology, it's a technology that allows you to wirelessly connect things over a very long distance with very cheap base stations. So you can already reach a distance of around 10 kilometers. You can collect all kinds of small devices that actually last on a battery for very long, and you can build networks with it. So if you have different base stations, like that's your, for instance, your Wi-Fi access point, and they can all work together as a big network connecting 10,000s of devices. So that was super interesting, because if you compare that to existing technology like Wi-Fi or Bluetooth or even your cellular phone, it's not that long range. And if it's long range, it's very battery consuming. So you need to have that power efficiency if you want to do Internet of Things. If I want to like connect all the chairs in this room, I need to make sure that that I'm not also need to recharge every chair every night, like I do with my cell phone. So super excited about the technology, and actually the B2B business cases were already being invented at this time with this technology. So this is, for instance, is a smart mousetrap, and it gives a signal when a mouse is caught. So it's like better hygiene. It is more efficient for your workforce. So this actually makes a lot of sense, because either checking all the mousetraps that you have as a facility management company, you now only have to send your people to the mousetraps that actually caught a mouse. So it's better quality, it's lower cost. So actually there's a business case behind this technology. So I was discussing this with my friend Johan, and a co-founder of the Things Industries and CTO, and we thought, okay, this is super exciting technology. And if it's like for the Internet of Things, where is the internet in the Internet of Things? So we thought, okay, let's build an internet for the Internet of Things. Let's see where we can copy like what made the internet great. And let's see where we can build a first network for the city of Amsterdam, because these base stations, these antennas that connect the devices, they have a range of 10 kilometers. So imagine drawing circles with a range of 10 kilometers over Amsterdam. You only need 10 of these gateways. So we got all excited about the technology, about the business case. And then we looked, okay, like if we want to make this grow like the internet grew in the past, so what is the core principles of that internet? Is that, first of all, it's shared infrastructure. So all the cables, all the routers that make the internet is actually a distributed system. Like all these different cables, the different routers, are owned by different entities, yet together they create the internet. Right? Okay. Second one is an open protocol. We now know it as Internet Protocol. So we need to make sure that on that infrastructure, there's a common language that makes sure that all these networks talk the same language so that they all can work together. And the third one is ecosystem of companies that make applications, of companies that make these technical components to make sure that the technology is adopted. So okay, these are the three ingredients. Let's see where we can replicate that. So we started off with at the Internet of Things meetup in Amsterdam. Jo and I were presenting there, and we said, okay, we want to make a decentralized system, just like the internet, for the Internet of Things. And we told the story, like, if in Amsterdam we can set up these different base stations, we built the infrastructure. If then we connect them all together through a common protocol called LoRaWAN, we make it a distributed network that works together. And then if we create an ecosystem of app makers, then actually it's being put to use. That's where the business case is. So around 10 people got excited from the 100 people there. We created a plan. So first one is to create the infrastructure and the common language. So that's what the technology team then at the time started working on. And the other one is that we needed to find companies that saw the potential of this technology for themselves or to innovate with, and that would invest in that shared infrastructure. So we had all these companies in Amsterdam said, okay, yeah, give me one base station, was €1,000, and put it on the roof and make it work together as one network. And it was very interesting. So we had companies like Deloitte and KPMG. They wanted to see how this could work for their customers that were in logistics. The Port of Amsterdam, they had all kinds of ideas about measuring what with sensors in their port that actually was really hard for them to get that data. So they all had their own business cases, and they wanted to contribute to this and wanted to experience this new technology. So within 6 weeks, we created a city covering network for Amsterdam, completely covering it with all these companies and this ecosystem of developers. So then we launched that with an event. So this was at our office at the time, at our co-working space, and we launched it. And at that meeting, we recorded everything, and we said, okay, what we did in Amsterdam, you can replicate all around the world, right? We open sourced it. And the reason why we wanted to open source it because we saw that it was actually pretty hard to build these solutions. And we thought we can only solve this by working together as an ecosystem. So we opened up everything we did. We created an open platform. And we said, let's build this thing together. And within a week, we had applications from all around the world where people said, okay, I want to create the Things network in Sydney. I want to do it in Boston. I want to do it in Sao Paulo. So we gave them a platform to easily recreate what we did. So what we did is we all the like technical complex stuff we solved, we gave to them, said, okay, build it yourself and improve it. Right? Like take it and improve it. Until we have something more gradually more mature and more solid. So super cool ideas and concepts came from that. So for instance, a company called Airnaas, they created a sensor they put on a green sea turtle for scientists to track them. And then the sensor gives a little message when the sea turtle comes on shore. So they know, actually, that they have to go to the turtle to find a data logger. Super cool. So they started up with this innovative concept. And of course, then you see that people and businesses from the maritime industry, they say, okay, this is pretty cool. If you're going to do it with a sea turtle, then for instance, you can do it also in my operations in maritime. And this is in Japan, where the Things Network was used as well to transfer data of sensors that measure the radioactivity around nuclear plants. We all know what happened at the Fukushima disaster. And this company, organization, is mapping the radioactivity with this device. And they're creating a map on how the radioactivity levels look like in Japan. And of course, you need to transfer the data to make sure it's in one data store and that you can show it on a map. Another concept that was embraced by the New York City, actually by the Manhattan City Borough, they had the problem that they had social housing and they had outsourced the management, and these management companies were not following the rules. So they were not putting on the heating when it was freezing in the winter. And to check them, a local community created temperature sensors they put in that social housing that automatically generated complaint report. So what here happening is it's a bottom-up innovation of a problem, a real people problem, the tools they can use to create the solution, and then actually create an impact, because now they have all this data. That is the proof that actually their rights are being compromised. So they have now a website where they say how many hours of violation these landlords are actually at. So this ecosystem started growing, maturing, and more and more communities and more developers started joining this movement. If you look at where we are right now, is that we have around 21,000 gateways around the world and 500,000 devices connected. And now with this immense network across more than 150 countries, we're routing around 9 billion messages of data a year. So this makes it almost the biggest IoT network that currently exists in the world. So let's look at a bit more data here. So in 5 years, we created an open source movement, an open IoT network movement, and a lot of tools for everybody to get started with this technology in an easy way. We come together every year at a big conference. This is always the last 2 days of January in Amsterdam. And last event, we had 1,500 developers from more than 60 countries, and we had more than 100 speakers, where this online community comes together and exchanges ideas and creates new stuff. So that's really cool. So what's our mission with the Things Network is that we want to bring you from 0 to 1. So you have an idea, you want to use sensors, you want to extract data from a thing, and then actually you want to go to having that product. And because hardware is so hard, because IoT is so hard, we are providing all the tools to make that life easier, to reduce your time to market, to reduce complexity, and also to reduce the risk that comes with these projects. So if you build IoT, you need to do a lot of stuff, right? So if you want to build something, you have to have the sensor, the gateway, and you have to bring it to a platform. And if you then look at why are we trying to save the time of developers, it's because of this, right? So from the 7.7 billion people in the world, there's only 25 people that don't know how to program and are developers, and that actually are able to deliver production level code. Almost 10 million of them are legacy Java ARP developers. So our estimation is that the group of people around the world that actually is capable of taking on an IoT project is somewhere between 0.5 and 1 million. So if you look at this for any project manager, any product manager, it's like, don't waste a developer's time, right? Like, think again when you're writing your requirements. Think again when you're briefing a developer, because actually their time is extremely scarce. So if we can build tools, if we can build anything to save their time, we're doing a good thing. So that's what we're trying to do. So if you look at building something this yourself, you need a device that looks, for instance, something like this. And this is an example of a gateway. This device tracks the location of this device, and it tracks movement and some temperature. And this is a gateway, and it can receive the messages from this device. So this, you can compare this to a Wi-Fi router. This is a GPS tracker. So, but this is an example of device. But if you look at already the ecosystem of devices that support LoRaWAN around the world, it's immense. It's going through this very, very fast, but this is really an abundance of smart meters that measure how much electricity or water usage there is, a water detector that measures a leakage, you name it. Like there's tons of the use cases. These are these gateways. You can have them like indoor, like this. This is around $80. And you have an outdoor version, which is a bit more rugged, and you can put outdoor, and of course also has a longer range. And the other thing you need to put the data somewhere, either something that creates rules like AWS IoT or Azure IoT Hub, or you have your own ERP, like you use SAP or low-code platform. It doesn't really matter, but the data is forwarded through HTTP webhooks or MQTT. So these are the basic building blocks, and what we're trying to do, and what we're doing here is that we're trying to make to reduce the complexity and hide all the complexity of all this radio frequency technology behind simple APIs. So the more we made it easier, the more we de-risk these IoT projects, the more we decrease the time to market, the more the business cases started to fly. You're removing cost, you're removing risk, you're moving time to market, it gets better. And then, all of a sudden, you need to solve other problems. So people were telling us, okay, we now made it from 0 to 1, and now we need to go from 1 to 1 million. But then all kinds of other problems arise. So people say, okay, how can we comply this to GDPR regulation? How can we make sure that this really fits into our IT architecture governance that we worked so long on? How can we make sure that this fits within our policies on how we are building, how we're approaching the cloud? How does this fit our security policies? So we started to work on tools that actually focus on that. And because you're in an enterprise market, doing this open and giving this away is not the right model. This is a commercial model. This is something that goes into agreements that we have to do. And there we created a company, the Things Industries, that was able to service companies around the world, creating IoT use cases in their critical processes. So, for instance, one use case is what we're doing in Australia, together with a subsidiary of Rabobank, is that we have a device that tracks cows with an ear tag that is sending information about the cow. You can imagine how valuable that is. Like, it detects if a cow is sick, or if it needs to give birth, or all kinds of data around the cow. And in these areas, they have very wide fields, so that's also good for them to keep track of them. Another customer of us is Wilmson. Wilmson is the largest ship management company. So you could see them as a company that helps you make sure that your ship is running in an optimal way. I'm not talking a ship like here in the canals in Amsterdam. These are ships that cost around 300 million each. But they have a lot of operational processes that you can check. So for instance, we're working on condition monitoring, where we are detecting how systems perform, and then the Wilmson can plan optimized maintenance on these ships. So it looks a bit like this, what we're doing. Another customer of ours is Deutsche Bahn, the German railway organizations, and in the next 3 years, we're going to put a LoRaWAN network on every railway station, and they use it for all kinds of things. So they use it, for instance, for making sure that the clocks run on time. We use it to make sure that the temperature of the platforms is measured, so they can give signals to when it freezes to the workforce that needs to throw salt on the platforms, for instance. And these are just two examples of what you can do with Internet of Things in a railway station, but actually the use cases are endless, because you can imagine how much you can know more about this. And of course, together with a partner, we're also servicing ProRail in the Netherlands. This is an interesting use case where in Switzerland they have these daily free paper in the public transport, and what it does, it measures when a stand like this is empty. So this means that if it's empty early, you're actually running opportunity cost, because if you would have a larger stack, your commercial reach would be bigger. So then they can level out and say, okay, I have to put more here than there, and then they build up that data, and they actually are increasing their reach. So it's not only it's not only about, let's say, bottom line efficiency, but this is like a business case around top line growth. It's like you're growing your business with IoT. This is a company that makes sensors, soil moisture sensors, salt sensors for agriculture. And we're living in a global water crisis, which we don't feel as a crisis, but actually we do. And this is able to measure the crop fields and measure what is the moisture, and then you can do precision irrigation, saving a lot of water. Another customer of us is WeWork. Together with WeWork, we help them optimize the real estate because we're putting sensors in their meeting rooms, and these sensors measure the occupancy of the meeting room, and in that way they can see, okay, is it fully occupied, and then they can optimize, because you can imagine that a square meter of space that is office is direct revenue. A square meter of meeting room is overhead. So you can imagine that you can optimize for that. And this also, again, it's a top line growth, revenue growth business case. It's not only about the bottom line efficiency. This is another interesting example. Most of electricity around the world is transferred over cables on wooden poles. They can get, like, by wind or by being rotten by water. It can start to, like, be flexible, and this sensor detects whatever it's actually gonna break in a certain amount of time. Again, here an outage in your electricity system is extremely expensive. Putting a small sensor on there that can make sure that it detects that it's almost breaking and preventing that is a huge benefit. So I tried to explain how, with an open standard, with shared infrastructure, and with an engaged ecosystem, you can make all these use cases that either make your business better, your life better, or society better. And we are constantly trying to do that by making sure that the developer is de-risked, and enabled. And if you want to get started, we made it super simple. You can get a very simple starter kit. Doesn't cost you more than €100, but that is not the thing. That is solved. What is the thing is that create a business case, right? Create something that you know will create value, and that will actually make these Gartner and McKinsey-like predictions of a huge market with billions of devices really fly. And it's not the technology push; it's actually the pull of this of the value that the business case brings. So I want to wrap up with that. Thank you very much for your attention, and I hope to see you all soon.